Um, so I'm happy to welcome you to session 2, a session on AI and deep learning on this year's Lübeck Summer Academy. And yeah, we decided this year to have a local focus and focus on exchange and collaboration. So we are starting the session with a keynote by Professor Wolfgang Wahlster from the DFKI, the German Research Center for Artificial Intelligence, who are also one of the newest members of Lübeck's family of AI institutions. And we will then have a talk by Hans Meine from Fraunhofer Mewis on an AI collaboration toolkit that aims to simplify working together on medical AI. And then we have 2 talks by heads of companies from the north of Germany, by Arpad Bischoff and Dominik Burzivoda. And yeah, the 2 companies are actively bringing AI in medicine forward, and they will share their experiences. And yeah, I'm really excited. So in front of us, there's a line of excellent speakers, and I'm looking forward to the discussions. The first talk is by Wolfgang Wahlster from the DFKI, as I said. Professor Wahlster studied computer science early on and was a professor of artificial intelligence at the Saarland University, where he laid some of the foundations in natural language dialogue systems, speech-to-speech translation, and so on. And his current research areas are in human-centered AI, and he's also the founding director of the German Research Center for Artificial Intelligence and longtime CEO and scientific director, and today serves at the DFKI as Chief Executive Advisor. He is and was on different boards from UC Berkeley to Germany's Platform for Artificial Intelligence. He's member of the Nobel Prize Academy, the Leopoldina. He received the Bundesverdienstkreuz for his scientific work, and among many other awards and honors. He currently heads the steering group for a national AI standardization roadmap of the Bundesregierung. And I'm very happy that we have him with us today to hear about his work in this area. And unfortunately, maybe, or for Professor Wahlster, fortunately, he's giving another talk in front of the leadership of German industry today and will therefore not be able to be present at the keynote this afternoon. So we will have some time for questions directly after his talk. And as in the last session, the following talks will be shifted a bit due to this, but I hope that everyone is fine with this. So very warm welcome to Professor Wahlster. I'm looking forward to your talk.
Thank you very much for the kind introduction, colleague Lotz, and I'm very happy to be here in Lübeck, because the standardization roadmap for German AI was published already 1 year ago, but it is now in the progress of being realized. So the next steps I will discuss soon in my talk. But first, let me introduce the institution I'm coming from. DFKI, the German Research Institute for AI, is a public-private partnership with many shareholders from industry. You see here 45 professors. Budget in 2020 was 220 million euro. And most important, we also have a site in Lübeck, concentrating on medical AI. So we are here in the right place. This was just opened in January this year. It's a new branch at the University of Lübeck, and we received start funding from the state government of Schleswig-Holstein of 3 million euro. And there are 3 professors working in this area already with groups on AI and medical imaging, headed by Professor Handels. Artificial intelligence and biomedical signal processing, very important, headed by Professor Mertens. And finally, another very important topic, especially for my talk today, is stochastic relational AI in healthcare, headed by Professor Ralf Möller. And here are some of the research highlights. I can't discuss them, but you see them under the aspect of regulation. Very important is, for instance, to have really causal relationships so that systems can explain their diagnostic results. This is done in this research unit. Or to reduce the necessary training for deep learning data to a realistic order. Today is much too much, and we don't have these data in many applications. Or exoskeletons in rehabilitations, AI methods for motion compensation, and so on. Very interesting cooperation with industry, with Träger is, for instance, the Dream Guard apnea detection. Just to give you a small hints about some of these very interesting new research projects here in Lübeck. But let me start with my core topic. We introduced, we means Professor Kagermann and myself, we were commissioned by the government, Angela Merkel herself, to steer the IT funding and so-called future projects starting in 2010. And we had to work on 3 large-scale industrial projects. This is Industry 4.0. This is, of course, AI or learning systems, and it's smart services. And for our domain today, medical applications, we can say, okay, for instance, yesterday we had a big discussion with BioNTech and Boehringer and so on about the production of individualized medicine, because this is new. Because today the factories we have for medical pharmaceutical products, we cannot use because they are geared to very high volume. And what we need is smaller batch sizes, because with individualized medicine, of course, you need a lot of variation to be produced very fast. And therefore, we have this new concept of smart production facilities in Industry 4.0. But we are not only looking to smart production, we are looking at the smart devices. For instance, I will discuss later in the talk devices for handling diabetes. Yeah, and this is the end consumer device for the patient. And again, here AI plays a very important role. So both in smart production and smart device. But finally, let me point out that when you really want to have a commercial success, you also have to implement smart services on top of these devices, like you have the apps on your iPhone or your Android device. And the same is now true for many medical devices, that they come with apps and smart services, which include, again, AI. So you see the circle that there are always data involved and AI involved, and this goes from production to smart service. Our strategy in Germany was to introduce in physical products, where we are very good at, on the international export markets, we inject AI. That means we don't throw away these things like cars, manufacturing equipment, and today medical equipment is what we discuss. Here we want to inject AI. Why? Because this gives a new quality, a smart medical device. What is the difference? In the first wave of digitalization in healthcare and in medicine, we had just digital data, recording, storing, transmitting, and processing. But you saw all the people using this data looking at screens, PDF, Excel, or whatever, or databases. But now we come to a second wave. The second wave is a wave where we use this digital data to automatically try to understand this data. Understanding not on the human level, this would be too much right now, but understanding in a sense that in the given domain, we can draw some conclusion and then use these conclusions actively to do something. I will give some examples later. Refining this data, and finally also we want to make some money, so to monetize these data. So the move is now in medical data processing from machine readable data to really machine understandable data based on AI. And second, we are also in the age where these medical devices are no longer driven by just input from typing or input from pointing, but we can use more and more, and this is very important for medical personnel, speech, graphics, gesture, facial expression. Even the physical action is sensed by the sensor or biometrics. This is much faster, much more robust, less ambiguous, more expressive, so that we go this way. Of course, if we do it, we need trust. And this is the core of this talk, that how can we ensure that people really accept this in practical settings? There is a high demand for testing and certification. TÜV has asked 1,000 German managers in industry, what about AI certification? And everybody said, you know, AI solutions must be clearly labeled for the users, whether they are certified or not. And especially in medical devices, it's absolutely necessary, as we all know. They should only be placed on the market, these products, once their safety has been verified by independent agencies. Just on Monday, we founded a new agency, a subsidiary of BSI, the German Agency for Security in Information Processing. And also TÜV is very active in this, and some institutes like Fraunhofer and DFKI have this task to give labels. Yeah, and this is absolutely necessary, and we will go more deeper how we can do this. The trustworthiness of AI products should be certified by independent testing organizations, and of course, we need legal regulations. Here you see our team, only the 18 members of the steering board, but altogether 300 scientists and industrialists worked for more than a year on the German roadmap for AI. And this roadmap was translated and is now given to the European standardization organizations, from DIN to CEN, and also, of course, ISO in the United States, the worldwide organization, or W3C, the Worldwide Web Consortium, is involved. This roadmap was handed over to the German government in October 2020, when we had the so-called Digital Summit. And this is the group, which was 1/3 people from industry, 1/3 from academia, and 1/3 from the German government. I was the chair, together with my colleague, namely the CEO of DIN, of the German norm standardization board. But this was not the only committee. Before, I worked on the so-called Data Ethics Commission. They also provided the English and German version, more than 300 pages and more than 70 regulation proposals. There was the Enquete Commission on AI of the German Parliament. And finally, we have the National Platform for Learning Systems for AI, where I was also involved, where we also have a group on standardization and data ethics. So you see, there was a lot and is still a lot of action in this field. So what what are the outcomes? First of all, there are basic topics. So we went through the whole field of artificial intelligence and identified more than 40 different subfields. So it's not only, many people talk about just machine learning and say this is AI, this is nonsense. Of course, there are many other methods which you need to know and which you use actually a lot also in commercial systems. For instance, automatic planning systems. When you go to therapy, I would not recommend to do this with deep learning. The diagnosis, there deep learning plays a large role, and so on. So we classified all these AI elements and showed which different AI technologies can be used in this connection. Then we had groups on horizontal topics like safety, privacy, security, the legal framework conditions, and so on. And then we went to the application areas. And today we are discussing the health issues. Health was one of the sections in our report. About, I think 20 pages were spent only on the medical domain, but we also worked, of course, on industrial automation, on mobility, and so on, up to agriculture. The outcome is a book, as I said, officially published as a book in November 2020. You still can download it also as PDF in German and in English. One important result was that if we want really a conformity assessment of a certification, we have to go through many levels, not only inspection, auditing, or validation. In the best case, of course, we want verification. Verification for AI algorithms is, however, quite hard. Where you can expect the verification today is, for instance, if you buy an airbag for your car, the airbag control software is really formally verified. Verified means there is a mathematical proof that this software is absolutely bug-free. It 100% conforms to the specification. Unfortunately, such a verification is only possible in some subfields, sub-algorithms of AI. For instance, a verification of many learning algorithms, especially the neural network algorithms, is not possible. Not today, even in the future. It's inherent. There is some uncertainty, but validation, of course, is possible, and we can go to a very high degree of reliability, and we need this, but a full verification will not be feasible. Anyway, this was our idea. And let me discuss the different phases of AI research, because the issue of having a trustworthy AI came only up during the last 10 years, because there were more and more, let's say, risky applications, from military to legal applications to medical applications. And we are, for instance, also working applications in fraud detection, forensic systems for Europol and so on, where trustworthiness is extremely important. In the first phase of AI, and this started already with the Dartmouth conference, where we have the anniversary actually the coming Friday. I will give an interview on Deutsche Welle on this. This was the time when AI was founded. This was heuristic problem solving. For some of these algorithms, search algorithms, you can prove that they are correct. Then came the era of knowledge-based systems for a long time, where you have manually encoded knowledge. Again, you could not prove that the knowledge is correct, but you could prove that the inference engine works correctly. And then you could look whether you believe in the knowledge which was used or not. Then we had the big area of machine learning, which was really a success based on training of mass data. But now we are in the fourth phase, where we say these are cognitive systems, where we bring together some structural knowledge, causal knowledge, together with machine learning. Because in machine learning, we experience that unfortunately also pseudo correlations are learned. And if you provide bullshit data to these machine learning algorithms, of course, you get garbage. And this must be, of course, strictly forbidden. So how can you do this? You apply some filters. For instance, if a physical law is invalidated by the correlation the machine learning is suggested, then forget about the result from the machine learning. Such filters are used heavily. We work also for Google quite a lot, and in Google about 70% of the results of machine learning are discarded, thrown away, because they are filtered by a knowledge graph, because otherwise false knowledge would be published. But the 30% which are learned are very valuable, because of course this is the big success of machine learning, that you sometimes find things which make a lot of sense, and especially if it comes to the sensor data interpretation, you cannot do today without machine learning. This is also pretty clear. So what we have is a connection. This is called hybrid AI. And also in the US, there was just last year a new program was started, AI Next, with $2 billion, where they say this is the next wave, the third wave of AI, because the first wave was handcrafted before the heuristic systems had no real commercial application. But in the beginnings with this manual knowledge, there were quite some, also in medical context, some good expert systems which are still in use to do some measurements and diagnosis, recommendations, but then very heavy second wave with machine learning, and now we are in the third wave where we bring the causal knowledge and the statistical knowledge together. So one could say we are now in the age where contextual reasoning, statistical reasoning, and handcrafted causal relationships are being integrated. Why do we do all this? What we want with smart services and AI in medical systems is that these systems can work autonomously, or at least semi-autonomous, without human interaction in some situations. I come back to this with the example of diabetes. The insulin pump should be run automatically by the results of measurements. Proactive is clear that the system should provide important information when necessary and not only when being asked. Adaptive to the situation and the users, and very important, self-explanatory systems which explain their own reasoning and can explain their recommendations. Self-learning I discussed, self-healing in some sense is possible today with simple robotic systems, and all of these systems should be, of course, interoperable and collaborative. We have developed over the last 10 years what we call AI on demand, a lot of building blocks where we can assemble complex AI systems. Now you could say, then please certify the different building blocks. But this doesn't help, because sometimes only through the complex interaction of these building blocks we get a good result in sensing, understanding, and acting. So now we have to go deeper into this. What are the main challenges? Of course, the uncertainty, the treatment of vagueness, the incompleteness of knowledge, and resource restrictions. Especially in medical context, if you are on the intensive care unit and need to act, you cannot wait hours for a result of the AI system. The AI system has to work in real time on the streaming data. Otherwise, it doesn't make sense in this context. There are other contexts, of course, in medical research, for instance. If you try to find a new medical pharmaceutical product, of course, you can use a lot of machine cycles to test different new compositions of such a medicine. So in basically we have we want to combine machine learning with a knowledge-based inference. On one is kind of knowledge-free; it's just based on the data. And here the deep neural networks, as we all know, are really excellent. We use them all over. On the other hand, the knowledge-based AI systems with search, inference, planning, and terminological knowledge are very good to combine or to complete, or, as I said, unfortunately, sometimes we have to correct the results of machine learning with this background knowledge. This is often done, Google does it with a so-called knowledge graph. This is an enormous data graph of knowledge, which was extracted, for instance, from Wikipedia, from physics books and textbooks. And these are the constraints which are used, and the system always checks whether the output of the neural network is conform to this, what we already know. The problems of deep learning for the certification are sometimes overfitting. You don't know when you have to stop the training. If you train too much, the system will get worse. I had my own experience with not a medical situation in this case, but in autonomous driving. We worked for NVIDIA, and actually we trained the car and everything worked well. It went 70 kilometers alone autonomously, but then it went, off the street. Why? There was some overfitting. It found in the videos we gave the system that at a certain angle of the sun, the car always goes right. And we checked this in the data, and this was just, spurious data. It was, there is no physical law, there is no intention of the driver like this, but the system found this in the data. So that the system suggested, now the angle of the sun is 37 degrees, let's go right. Yeah, and this is a complete nonsense, of course, because there is no causal relationship between steering and the sun. But in the data, this was it. So we trained a little bit too much before the system worked very well, but then it found this correlation, which is actually not a causal relationship. So we have to discard this. Or we have missing data. This is very important for in clinical studies. Again, in the car driving situation, of course, we don't have data where a small kid runs in front of the car. The same in medical situations where we want to check something for a very rare illness or disease. Of course, then we work sometimes with synthetic data. Also, these systems cannot extinct what they have learned. Once they have learned something, you cannot tell the system, oh, what you learned is wrong, please. You have to start over and over again. The explanation capabilities, as I said, are weak, and sometimes there are false alarms, but this is known as statistical ways. Therefore, we say we have to be a little bit self-critical if we apply this, especially in the health area. And we introduced a pyramid, which we call the risk adaptive regulation, with 5 different stages. The European Commission adapted this. They only want to have 3, but it's not. The German government had a protest, and I think it's not still released. This one, as I explained it, is released. The European one is not yet official because some countries, including Germany, have concerns. But anyway, if you have 5 different levels, the biggest level, and you see this in green, is a level 1, where you have a harmless application, no certification requirements at all. It doesn't make sense to regulate everything. Most of the applications of AI don't harm anyone, so you can use them. Then there is an intermediate area where you should be a little bit careful, and regulation should start. So there are certain criticality values, I will explain in a minute, where you have to do something. But only in the upper level 3 and 4, a real formal certification starts. And then at the end, on level 5, there are, of course, also applications which are so, have such a high potential to damage that they should be forbidden. Yeah, for instance, in Europe, it's not allowed in medical research to do with patients, not the neural waves can be analyzed, but you cannot manipulate the human brain by magnetic impulse. So that means brain-to-brain communication, in the sense that you think the guy on the other side of the internet line should now have his gun and shoot somebody, and this is triggered by manipulation by magnetic devices of the brain, should be forbidden. This is possible. It was done already. I was myself have experienced it, but not here in Israel, and it was very interesting to see that really the system can force you against your will to press a button, for instance, a very simple thing. But such manipulations of humans, of course, are not allowed. So we don't need certification. It's simply illegal to do this. And I think everybody sees that this, for ethical reasons, we cannot allow something like this. Brain reading is positive. This is okay. It's already done, of course, quite a lot in medical situations. Now, let me give a concrete example. We did this, for instance, for machine translation. In machine translation, fortunately, there is a clear measure of how good the system automatically translates. This is a so-called BLEU value. And if you have a BLEU value of 35, you can say, okay, with such a machine translation system, you can use this on a public news channel to translate from Japanese to German, for instance. In a technical handbook, okay, you have to be more careful, because if you give a user a wrong translation, we had this with Chinese products for a long time, that the handbook contained, wrong explanations, and there were even some accidents where people did something wrong because they didn't understand or even understood in a false way this instruction. So here it becomes more critical, BLEU value over 40. And especially in our domain today, if it comes to medical letters, for instance, you receive as a doctor a medical letter which was produced in, let's say, Vietnam from your local emergency doctor. It's in Vietnamese. Now you want to read this in German. Of course, this must be a high level of trust. Yeah? And as I said, the European Commission says today, if it's a testimonial in the European court, you need special human translators. We cannot accept automatic translation with AI. Why? Because this translation sometimes even misses a negation. So you say it has not happened, that the guy did this, and the translation says it happened. Yeah? And this is, of course, not tolerable in a legal situation. So I think you see that we can do this. And of course, it's a little bit more complicated. In most cases, we don't have such a simple metric. The metric is much more complex. So, and we also have to look whether this is done in a critical situation. For instance, you talk about autonomous vehicle, which can go quite a high speed, or you talk about autonomous garbage truck in a city, which goes only up to 20 or 30 kilometers at most per hour, so quite slow driving, where you can say, okay, yeah, we can be a little bit looser. And the same, of course, is in medical applications, that we say, okay, if this is a disease like headache and so on, not very, or you have just a small infection, then it's less critical than when you work on the intensive care unit. This is, of course, clear that you have to consider the application context and cannot say that there's an absolute value. And we do this also in all these committees, as I said, not only DIN and DKI in Germany, but then CEN, CENELEC, even ETSI has a group on this, and of course, ISO. Our top recommendations to the government, which are now rolled out. We have a new group, as I said, which was established by the Ministry of Economic Affairs and Energy, BMW, and the Ministry of Education and Research. Just 1 month ago, we had the first opening session, and we said, okay, what we want to do is now we have to design reference models for AI data and architectures, because we want to make sure that these systems have interoperability. Second, we want to establish, of course, a security guidelines. As was asked before, we need practical criticality criteria and tests. So we have to establish test clusters and people who really do the engineering, so that these tests can be very speedy and not too expensive. We implement a national program, Trusted AI. Here, DFKI in Fraunhofer, in Billinghoven, EIS, is working together with BSI. And finally, investigating the need for standards and test profiles for specific use cases. The interoperability issue is important even for the data, because many people are a little bit naive in this. For instance, in supervised machine learning, of course, we need to use standardized ontologies. Otherwise, if you annotate the data in a random way, let's say in Lübeck University Hospital in another way than in Charité, then you, of course, cannot use these two data sets in as a common training data set. So we need to have standardized ontologies, and this cannot be done by machine learning. This is manual work by experts. And on the other hand, we have to make sure that the data which is provided is also consistent. Because if you have many so-called click workers, often companies go to India to have cheap click workers or do some so-called crowdsourcing for getting the data annotated. Of course, you get a lot of garbage, because these people sometimes are not trained in the domain and click to concepts which are not the correct ones. And we all know, if you mix very bad data into very good data, what you get is again garbage. Yeah, and therefore the consistency checking is extremely important. I just gave you 2 examples from streets where you say, okay, do we talk about bicycles, motor bicycles, and so on? This is, you must have clear standards how you annotate this. And I just wanted to show again in the domain of translation one example to show the domain dependence of the training data. We have tested in the last year for the European Commission 6 different AI-based translation machines. And all of them are based on machine learning. So you have large data sets of translated data. Now we made the experiment. When you use this in a legal context, so you have the data from the European court translated, they are translated to all European languages, and you enter the French sentence, je mange un avocat. Then you get the result in German, ich esse einen Anwalt. everybody says this is crazy. Yeah, you can't eat a lawyer. But why did this happen? Because we chose a translation system which was trained on data from the legal court, not on common sense or normal data. And exactly, you know, in France, the word avocat is ambiguous. It can also mean the fruit of avocado, which is avocado in German, or Anwalt in German. Both translations are possible. If you train the system only on legal, then the system does such a big error. The word knowledge is missing here is that we have not cannibalism, so I cannot eat a lawyer. So the correct translation, of course, is avocado. Ich esse eine avocado, but this is the dependency on the training set. So I have to speed up a little bit because otherwise we have no time for discussion. But let me point out that now it's a time to start with AI certification hubs. And the first one was just when you watch TV on Monday, you saw it, and it's in the press today very much, the new certification hub of BSI in Saarbrücken, which we do together with Helmholtz and DFKI, up to 100 people, as I said, from BSI to come up with these certification policies. So not only guidelines, but real certification procedures. You can expect this like when you go with your car to TÜV. It's a checking list. What has to be checked? How do we do this? Checking machines, some things you need special measuring devices and so on. And you can transport this to the domain of medical AI systems. This will be a very tough task. And of course, we need the help of everybody. And I understand that especially Lübeck has a lot of experience in this. And you have also the local industry, which of course has a big demand of getting the certification. So I think Lübeck will also be a very good place to establish such a certification hub. Let me discuss one more very important problem from my point of view. We always will have a cooperation between human agents and medical systems. Even if we have an autonomous system, from time to time, there are situations where the autonomous systems cannot get along with the situation and has to cry for help, as we say. If you once have tested a Tesla, where we have a Tesla at DFKI, we used it from Professor Scheer. And when we go to Frankfurt Airport from Saarbrücken, we have 3 times that the Tesla says, please take over immediately. Yeah, because the Tesla cannot go in the autonomous mode because data is missing or there is a situation which the car cannot handle. So we have what we call transfer of control. The autonomous system asks a human expert, please help me, I cannot go on. And what we have designed in several projects, one was Traktat, funded by the German Ministry for Research and Technology, that we say this system has to give you a situation summary. Why are we in a situation that you cannot go along? What is the explanation of the situation from your point of view? What are your problems? Otherwise, just crying for help, please take over the control. This cannot work. If you're in an intensive care station and the system would say, like the Tesla, please take over immediately and gives you no data, of course, even the best expert in medicine cannot take over because first, a situation summary on a level which is understandable to human has to be given and it has to be explained. And then the human can take over for a while. And then, of course, there must be also a controlled way to give back to the autonomous systems the control. let me discuss this problem in a very simple closed loop system where you have an insulin pump on the arm, you have a measurement device also on your body, and you have on the handset AI system running, controlling the insulin pump by the values you have. And this is a very simple AI system, but it works in a closed loop fully autonomously. And again, here you can say, what is the risk? The risk is not so high. I mean, the persons who have diabetes 1 know something may be wrong, the pump is not working, and then they can do themselves some injection of insulin. But of course, you see also the problem if the system cannot go on, breaks down, then of course the system needs help. And again, this should be in a trustworthy way, otherwise the customers and the patients will not accept this. And it was very good to see that the Diabetes Society has already such a certification stamp developed and has some criteria for AI inside, like transparency, trustworthiness, no discrimination of training data, no pseudo correlations, no fear of losing control by such a handover of control. So very interesting development. And let me finish by saying that I talked a lot about regulation certification, but of course we should be also very clear that we should not over-regulate, because what we are observing with AI today, that many of the big so-called hyperscaling companies from the US or from China don't do this. Yeah, they apply things where we will say this is not really trustworthy. There is no explanation component, but still you can run them. You know, pay for it and run it on your internet device. So, and of course, we have to be careful if we have good startup companies or big players in the medical domain. We have the first difficulty in Europe already, that the access to data is also limited compared to China. They have much more patient data. Of course, everybody understands patient protection is important, so we cannot circumvent this problem. But if it goes on and we have really very harsh ethics regulation, or now with the standards and norms, we overdo it for applications where we feel it's not absolutely necessary, then we are in a big trouble, because the people use the Chinese and US systems anyway, and we have a disaster in the economy. Here we are talking at Industrie- und Handelskammer. We have to see that our economy is also boosting, and it would be unfair as a hurdle run here if we take all these hurdles in Europe and the others don't care and make the big business. So this is my warning. We have to find the right balance. And today I talked about a lot of measures, but let me point out the big green area where we don't need this, and the upper area where we also should be very careful. Is it really necessary to have this? Yeah, thank you very much for your attention. You can read in the roadmap everything here if you download a PDF, and also the slides of my talk you can get from the organizers. So thanks very much to Lübeck for inviting me, and I'm sure we will open in November. After then finally, I think there will be no COVID anymore, I hope, officially in Lübeck, the new DFKI facilities, which are already operational since the beginning of the year. Thank you very much.
Yeah, thank you very much for your comprehensive talk and all these ideas. I think we should take a few minutes for discussion. So if you have any questions, please enable your video or at least your microphone. Go ahead or type your questions into the chat. And while everyone is settling for find their questions, I will start with one. So you said that it's impossible to verify deep learning based or neural network based systems, and still we are seeing a lot of these systems, especially in medical imaging or the medical field altogether. So what do we do about it? I mean, there can still be the situation that there's an input that wasn't expected, it wasn't part of the training data, and then we are not even sure that we can detect that we are unsecure. So what's your view there?
Very good question. Of course, we do a lot of research, especially on this question. And what it turns out is that we have some methods for at least finding out how the system came to this conclusion. For instance, we can have a heat map where we see in the CT or whatever picture, the video or the sensor data, where did the system concentrate to find this result? So it's not a real explanation, but at least it gives us hints, yeah, on which, and so on. I could now, we invented two methods. Also, the institute run by Professor Müller in Berlin worked on this, and so on. Yeah? So there is some progress, but you are completely right. A formal verification in the mathematical sense is not possible. As I said, these systems are often even not stable. You get a result, and later, as I said, with overfitting, the result fades away, and so on. So from a purely mathematical point of view, it's not possible, but very high evidence. We can go up to evidence, let's say 95%, you can really trust. There is always, and then you have to warn that there may be a problem. And as I said, as a doctor, I would always double check with my own knowledge. If the system really says this guy has now, I see COVID here, and no symptom is given, yeah, and this was a picture, let's say a CT of the lungs. There is some Chinese software trying to predict COVID on this such a image. Then you can say, okay, but for this patient, it cannot be. This is because the sensor was changed. This is unfortunately another small problem with the deep learning on medical data. It depends a little bit on the equipment you use. If you go from a Siemens scanner to a scanner from a, let's say, a Chinese or Japanese company or US company, then the results are not the same. This is not against deep learning. As I said, it's where we use it all a day. Without it, we cannot give good predictions. But we also should keep in mind all these problems. And I think it's very important that the end user, you are also from computer science, but we have to explain to the authorities in medicine, to the boss of the hospital, so to speak, yeah, it's very good, but also with a grain of salt, yeah, please double check with your common sense of medical knowledge whether this can be or not. A good example where we don't have any problem at all, if you check ray pictures from tooth as a dentist, whether there is caries. Yeah, they are very good systems. Sometimes they are wrong. But again, I always say, if you the system predicts one caries where there is no caries, the dentist will realize anyway. But it's very good that we have the system, because often it points out areas in your mouth which have caries which the dentist would not find. So here you see the combination of deep learning and machine learning with the dentist is very good.
Yeah, thank you. Do you have any other questions? There was, yeah, Professor Müller.
Well, I would like to come back to the handover of control from the autonomous system to the human and back, maybe.
Yes.
So it might be the case, like in chess, where a system plans for a queen's gambit, say, right? Then it seems for a while that a particular sequence of moves is not a very good one, but you know, at the very end, it might be the winning strategy. And couldn't this happen also in this, you know, loop, if you will? The system then needs to assess its own competencies in a way to decide whether to hand over or not.
Yes. I think that's a very good point. Unfortunately, I skipped this slide with the architecture, and you are completely right. This is the orange part. I hope you see it here. The orange part, the self-regulation. This means really that the system only should hand over to the user if it's very uncertain about its current strategies. And this self-knowledge is in our view extremely important for the next generation of autonomous systems. We already have it in some of our robots, yeah, for the energy management. They really plan their actions according to the level of energy they have, if they have a mission, and then they evaluate. If I go on with scrolling in this speed like I do now, do I reach my goal? If not, I go slower, because right now it's a big wind. The wind, heavy winds, and are working against me. So if I go slower, I wait a little bit, because in the evening maybe the wind is not so much, and then I can reach my goal. You see, this is, as you pointed correctly out, is a kind of self-consciousness in a very simple, of course, it's not comparable to humans, but still it works. And we have such systems implemented already. You're completely right. But from you, I would have expected also the support for my thesis you need to add causal relations, because I think you are the specialist here in this area.
I mean, the other point with the competence assessment, self-competence assessment, is the outer control, or there might be somebody pressing the emergency shutdown button, right? Yes. While in a Queen's Gambit, the system might be well aware of what happens next, has a clever plan, right? Whereas the operator doesn't realize this, and then shuts down the system maybe too early. I think there are very many tricky issues.
Yeah. Yeah, that's also a very good point. We studied a lot the so-called anytime algorithms, where you can put time pressure on the AI system, and the AI system tries to select a methodology so that it brings already a recommendation or a diagnosis in the given time frame, but it indicates that this is much worse. So anytime algorithms have the characteristics and mathematics that if you give these algorithms more time, the result gets crisper and more reliable. But if you push the system, as you pointed out, yeah, then it brings, but I think it always should be under the control of the human. What you indicated, that the system said, let me go, I need a half an hour, and then I come up with a super solution. I think you cannot trust. You should, as I say, I need now already a first result, and I will check this, whether you are on the right track, so to speak.
Okay, thank you. So Dirk Hermsmeyer raised his hand. I'm not sure if he wants to ask another question or he wants to remind us of the time.
Yeah, we have.
No, I would actually, if we do have some time, I would actually ask another question or give a comment. We already started to discuss this a little bit before your talk when you came in during our lunch break. I'm still. I'm concerned about the model that is introduced for either conformity assessment or state permission by a state authority, and I'm concerned by the mix of the two that seems to be coming up here for artificial intelligence. Many people in our audience today have a background in medical devices, and these companies, manufacturers, are used with working with the conformity assessment system. On the other hand, in medicine, we have the European Medicines Agency that takes care of pharmaceutical products, and that has become very popular in the last months of the pandemic with the vaccinations. So that's a state authority, but with medical devices, we have the system of notified bodies. What seems to be coming up here with AI-based products is a mix of two, where when the level of criticality becomes higher, the conformity assessment changes into a state permit at some point. And I see endless discussions coming up about where this point is. And also another point is the system fairly directly implies that only the state could be the best authority to actually judge about how an AI system should be handled. And I doubt that this is true. Going back to the experience with pharmaceutical products, there's numerous examples where also, for example, the European Medicine Agency was wrong in their decisions. And I know we have some people in the group, maybe Jens Uwe Hagener, formerly at Dräger. We discussed this or similar problems in our AI working group that we have. Maybe somebody can comment on this.
Yeah, let me try also to answer. We already discussed this a bit, but you are completely right. Of course, it's always hard to have the borderline. But on the other hand, you cannot give this away from the government, because I think the citizens of a state or country want this. You cannot, if you have arbitrary self-conformity checking by industry, you don't know whether you can trust it or not. So you are completely right that, of course, it's very hard for government agencies to have the right level of expertise. Therefore, they are now hiring people from science, from companies and so on, pay high salaries to do this, but they do this under the control of the government and you know, with money from taxpayers, not private money, because with private money you always can have a certain bias in this. But on the other hand, you are completely right, because there's so many checkings have to be done. Think about all the health apps for the consumer market. There are already 10,000 health apps, you know, which you can download from your on your iPhone. Who has to? This cannot be checked by the government. This doesn't make sense. Yeah, and therefore, of course, you need also other organizations. I would vote for what is established in Germany and is a worldwide thing which is recognized, is something like TÜV. Because these are agencies which are run as private companies, but which have a license from the government. If you have arbitrary people doing this as a job without license, I would not trust.
Okay. Yeah, and with medical devices, for example, you still have the state authorities with the vigilance systems in the background. So
yes. Yes.
Yeah. Thank you very much. Maybe we can continue this discussion in the panel discussions this afternoon. So thanks again, Wolfgang Wahlster, for being here today.
Thank you very much.
Bye-bye. Bye. Thank you.
Bye.